Hello everyone, in this video I am going to discuss about Euclidean algorithm. So here I am going to discuss how do we use Euclidean algorithm and where do we use it and its implementation in C++ language. So let's get started. So where do we use it? Where do we use it? So answer it, we use it to find HCF of two numbers. So the problem statement will be like this. Will be given two numbers. For example, let us take 105 and 25, and we have to calculate and return its HCF. Now what is HCF? So HCF is the greatest number which divides both the number. So in this case here HCF is 5. So 5 is that greatest number which divides both the number. There is no greater number than 5 which divides both the number. So here I am going to use two properties related to HCF to find the HCF. So what is the that properties? So HCF of any number a and 0 is a itself. So how it is? So I can prove it if we see it carefully. 0 is that number which is divisible by any number. So HCF of a and 0 do not depend upon 0. So HCF of a and 0 depends upon a only. So what is that number which is the largest number and divides a itself. So the greatest number which divides a and 0 is a itself, as HCF depends only upon a. So now this is proved. Now let us see the second property, which says that HCF of any two numbers a and b do not changes if I replace one of them with their difference. I can replace a with difference, first number with the difference, and also I can replace second number with the difference of both the numbers. In both the cases HCF of two numbers do not changes. So let us prove it. So consider there are two numbers a and b and their HCF is G. Now if G is the HCF, then we can surely say that A is divisible by G and B is separately divisible by G. Now if we want to find that if G is the HCF of these two numbers also, so let us check here. So for B we can directly say that yes, B is divisible by G, as we have seen it here. And for a minus b, let us try by dividing it with G. Now we can write it as a upon G minus b upon G. As a upon G, from here we can say that yes, a is divisible by G, and from here we can say that yes, b is separately divisible by G. So we can say that this number is also divisible by G. Similarly, we can prove it for this pair. So now let us see how we are going to use these two properties for finding HCF. Now let us take the same example, that is 105 and 25. Now if I replace the first number with their difference, HCF won't change. So HCF of this pair will be same as HCF of this pair, as here I have only replaced this first number with the difference, that is 105 minus 25. Now again if I do the same thing, 80 minus 25, that is 55, and 25, HCF will not change. And again if I do the same thing, that is 30 by 25, SCF won't change. Now if I do again, it will become 5 and 25. Now our first number has become smaller than the second number. I want to keep first number as a larger number, so here I am swapping again, as I can subtract again and again second number from first number. So here I have swapped. Let's mark it. Now we will repeat the process. We will replace first number with the difference, then again we will replace that, it will become 15 and 5, then it will become 10 and 5, then it will become 5 and 5, then it will become 0 and 5. And we want to keep the larger number, first number as a larger number, then we will swap it here. So let's mark it as we have swapped. This will help in future for observation. So it is a good way to find HCF of two numbers, but there is a problem. What if I give you one number very large number and other number as a small number, let's say 1. What if I give you these two numbers to find HCF? So finding HCF using this method will require 10 to the power 6 operations, very large number of operations to calculate HCF. So it is not very good method. So we want to optimize it. So how can we optimize it? Can we optimize it? Yes, there is a way to optimize it. So we can reach from here to here in one step, and from here to here in one step. So in two operation I can calculate HCF. So after reaching here, we can use our property 1, which says that HCF of any two numbers, and if one of them is 0, then HCF is the other number. So here HCF will be 5. So how we can get here from here? So you see, here we are again and again subtracting 25 from I have subtracted 25 from 105, 25 from 80, and 25 from 55, and 25 from 30. And if you observe here carefully, I have written this number here directly, and if you see, I have written here the remainder. Let me make it more clear. So I have written this number here, and here I have written the remainder of 105 and 25. So we can write it as, if A and B are two numbers, we can write HCF as HCF of A and B will be same as HCF of B and A modulo B. So if we do modulo operation here, we can skip these operations, because 105 is nothing but, we can write 105 as multiple of 25 into 4 times plus 5. So here we have subtracted 25 4 times and then obtained this remainder 5. So using modulo operator we can directly obtain the remainder, and from here also, from this step, which is 25 and 5, I have written this second number as first number here, and in the place of second number I have written the modulo of first number modulo second number. So here modulo of first number, that is 25, modulo 5 is 0. So we'll again and again repeat this step for calculating HCF. So using this step we can efficiently find HCF of two numbers. Let us implement this. So Here I am taking two numbers int a and b and taking them as input. So these are the two numbers for which we have to calculate HCF. So here I will write cout HCF. It will be a function and I will provide input as a and b to this function. So now let us complete this function HCF. So its return type will be of int. So its name is HCF and it is going to take two integer type arguments. So now we know that we are keeping first number as a larger number and second number as a smaller number. So if we perform modulo again and again, then the second number, that is b, will become 0 first if both the numbers are non-zero initially. So we'll check for if b is 0, and then we'll use property 1 and we'll return our HCF as other number, that is a, and we'll find our small answer, that is HCF of b and a modulo b. So here I am doing passing recursion b comma a modulo b as I have used here. So I have used this for performing this step, for performing these jumps. So the answer of recursion will be our answer, as HCF of a and b is same as HCF of b and a modulo b. So I will return the same answer as given by recursion, that is small answer. So let's try to run it. I am providing here input 10 and 5 and let us see the output. Yes, here it is coming 5, as 5 is the HCF of 10 and 5. Let me give here another number. Let me give 124 and 56. Let's see. So yes, it is showing the correct output, that is 4. 4 is the HCF of 124 and 56. So this code is working absolutely fine. So this is the two-line code for Euclidean algorithm. Hope you understood the concept. Thank you.